written down in their notes what we did in the video on this one? Just remind me. Paper that you brought with you? No. Okay. Anybody have this one written down as to what we did? What are you thinking, Miss Johnson? We took the square root of each one of these. What is the square root of 16x squared? What is it? 4x. Thank you very much. One on one side, one on the other. This is 3-4, question 10, which is part of the video that you already worked on. So 4x, and then we took the square root of 49. What is that? 7. Now, what signs would I want in there so that when you did the outsides and the insides, you ended up with 0x in the middle? What signs would I want them to both be positive, both be negative, or one of each? You would want one of each. That would create positive 28x and negative 28x. And it doesn't matter whether you put the plus in the first one and the minus in the second one or reverse that. This is your answer for that question. So when you have a difference of perfect squares, and you'll be able to tell, for one, there's only two terms. You've got subtraction in between. And both of the things that you're looking at are perfect squares. But that's how we handle it. We take the square root of the first, the square root of the last. One's a plus, one's a minus. The next question is not a difference of perfect squares. So as we did in the video, we can talk about how we would break that down. So, what are two things that multiply together to give me p squared? P and P. If you're overly hydrated, you have a lot of P. Now, we need two numbers that multiply together to give us 144, right? So they multiply together to give us this, but they add up to this. If they're adding to a negative number, but multiplying to a positive number, then they would both have to be subtraction. That is the only way you're going to get, stay with me. The only way you're going to get a positive product is to have two minus signs and a sum which is negative. Obviously, if the sum was positive, then we would have both positives. Okay, you come up with the numbers. What multiplies together to give us 144 but adds up to 24? Now, this part did not. There were like 3 or 4 questions that we didn't do on the 3-4 notes, which I just wanted to practice more of this kind of stuff. Here's a couple choices. But 6 and 24 add up to 30. And 3 and 48 add up to 51. So these are not good choices because they don't add up to 24. What should I have picked? 12 and 12. Several of you told me that. In the world of math, how do we show that we want to multiply something times itself? We use a square. So I would be looking for you to write this. Probably not, but might give extra credit if we go the distance. Anything times itself is squared. So now, a few minutes ago, I said this was not a difference of perfect squares, and you might have thought to yourself, well, we can't take the square roots like we did before, but this is this thing is called a perfect square. How many terms do you see here? P squared minus 24p plus 144. How many terms? 3. What's the cool term we had for something that had 3 terms? Trinomial. That is called a perfect square trinomial. Now, in a perfect square trinomial, some of you not taking this all that seriously. It'll come back to bite you someday. All right, now, could we take the square root of p squared? Would that have worked to find the first part? Could we have taken the square root of 144 to find the second part? Yeah, it would have worked. So we could have used that strategy in this case. Now, what was the difference between them? Look at the signs. What's the difference between the first one and the second one? One's got a positive and a negative. The other one has the same exact signs. So a perfect square trinomial are either both going to be positive or both going to be negative. And the only one that I can write as a square is the second one, right? The first one up there at the top, when you've got one positive and one negative term, you cannot write that as a square because those are not the same. Okay, next page. Is this a difference of perfect squares? Difference means subtraction? No. It's not a difference of perfect squares. You're right, because remember, that one only had 2 terms in it, and it was separated with subtraction. So, is this a perfect square trinomial? Well, we could find out, right? So what if we took the square root of the first term? What's the square root of 64x squared? 8? 8 what? 8x. She's just soaking up all the knowledge. Soaking up all the knowledge. She's my new assistant. She's my student assistant for 7th grade. Yeah. For real. No, she's doing math because she's learning, unless she needs to do something for a different class. But she's learning math. All right, now, what about the square root of 1? What is it? 1, right? Now, what signs should I put in there? Because we want the middle term. We want the middle term to be positive 16x. You're saying they both should be positives?
No, one of them should be a negative.
Okay, all right. If one's a negative, outsides would give me negative 8x. Insides would give me positive 8x. Those would add up to 0. I don't know if that's the right answer. Both positive? Let's try that. Let's try both positive. Okay, that's 8x and that's 8x. Oh yeah, that works. 16x right there. Okay, write your final answer. Go. Write your final answer. I want to see what you have for the final answer of this. 8x plus 1, quantity squared. Yes, this is just like the one we did before. 8x plus 1, yes. 8x plus 1, since they're both the same, you can write it as a square. This is a perfect square trinomial. Thank you very much. I should write that down. Perfect square trinomial. Yeah, see, I've noticed that some of you are taking good notes and some of you are not taking enough notes so that it makes sense to you when you go take a test. So perfect square trinomial. Question 13. Is this one a difference of squares or is it a perfect square trinomial? You're right. It is a difference of perfect squares. Okay? We're subtracting for one, and you got a perfect square in the front and the end. So, factor it. Go. So, since we decided it was a difference of perfect squares, we could take the square root of each one of these. What's the square root of x squared? What?
It's this video.
Okay.
You want me to show you?
No.
After class.
Maybe. So x comes from both of those. What about the other part? What's the square root of 121? 11. What do we do about the signs in between? 1 plus 1 minus? You are correct. And what happens when you have one positive and one negative? They cancel each other out. So when you do the outsides and the insides, they cancel each other out, which is why we don't see a middle term. Now, can we do something like this? No, why not? Right, they're both different. You can't say something is squared like that when they're not the same. I would not do that. I know what you're getting at there, and it's not the worst idea in the world, but I would say no. Let's not do that. Let's just leave it alone. So square root, one's a plus, one's a minus. Move it on. Oh, is there one more there? Or we got that one in the video, didn't we? Yeah, we got that one in the video. Okay. So let's move on to section 4.1 notes. Okay, so this is section 4.1. And solve this equation by factoring. So something's different here about this versus the last section. Are we still doing factoring? Sure, we're still doing factoring. But there's more to this question. So let's start by doing the factoring. What does this factor into? Do you think that is a difference of perfect squares? Or do you think it is a perfect square trinomial? What do you think? It's a difference of perfect squares. Okay, factor it. Take about
I already
15.
did it in 5 seconds.
Yeah, I was going to say, it shouldn't be that long. You're right.
Is this right?
That is right. Good job. X plus 5, x minus 5. Now, the difference is it's equal to 0, which means we have an equation. An equation can be solved, which is why the instructions were solve by factoring. Not yet. If you knew that two numbers were being multiplied together, let's call them A and B. If you knew that they were being multiplied together and they equaled 0, what would you know about one of them? One of them has to be 0. You are correct. So either A or B would be 0. Right here in this particular equation, you see that we are guaranteed that two things are being multiplied together and they equal 0. What do we know about either x plus 5 or x minus 5? One of them has to equal 0. That's what we do know. Solve each one of them and tell me what you get. 0 is not one of the answers. What'd you say? -5 and +5. Just by subtracting the 5 or adding the 5. Is it okay if I write plus and minus 5? Yes. How did I get what? So what I'm doing is I'm just taking the equation and I'm solving it for x. And here we get x equals -5. And here we add 5 to both sides and get x equals +5. One of the factors has to equal 0. So either this factor has to equal 0 or this factor has to equal 0. And so that's what we did. We set up these equations with the factors. X plus 5 equals 0 and x minus 5 equals 0. Solving for x is a separate question. And that's what we had to do after that. We had to do the one extra step. Okay. Now this one is not a perfect square, and it's not a difference of perfect squares, and it's not a perfect square trinomial. So this is going to, there we go. We need to use our factoring skills and think about numbers that multiply together to give us 6, but add to -5. If it's multiplying to a positive number, then either both of these signs are, either they're both pluses or they're both minuses. Which do you think it has to be? Either both pluses or both minuses? Both minus, you are correct, because since they have to add to a -5, we would have to have both minuses. All right, go for it. Factor it. Yes. Now set the factors equal to 0 and solve. Right? Minuses. Things that multiply together to get 6, but add up to -5. That is true. When it says solve, they just wrote down 3 and 2. Now, do I say things like, yes, set the factors equal to 0 and solve? Sure I do. But when you get good at this, is it going to take you a lot of energy and effort to understand? I mean, So for instance, Mr. Kondo said, isn't it just the opposite of what you see inside the parentheses? Yeah, truly it is. Now, if the factors get more complicated, then that's not necessarily true. But in our case, when we have nice simple factors like this, it is true. So I would not argue one bit if this person, I'm not going to sit there and say, oops, we'll leave it at red. I'm okay with them writing this. I'm okay with them doing this. Once they have it factored. I mean, I even see this, which makes me think that they've set it equal to 0 in their own minds. I mean, that's what they did. So I know that they're on the right track. So n minus 3, n minus 2, and then we come up with 3 and 2 as our answers. Are there any questions about that one? Yes. Okay, so when you do the insides and the outsides, like for me, I get negative 3n and negative 2n. For you, you would get positive 3n and positive 2n, but remember, they have to add up to negative 5n. So that's how you know that you should switch the signs. You know, it's really good if you, listen, focus. If they add up to the opposite in the middle, if they add up to the opposite, that is a good time for you to switch the signs, okay? I know some of you set your computer away, but talk me through this. So how would I factor this thing?
So you would put the parentheses.
Yep.
Inside you would put T.
Yep.
Minus on both of them.
Good job.
And then you would put.
Are they both 3? Yeah, that's true. And the final answer would be positive 3. Do I have to write the 3 twice?
No.
No, thank you very much. You do not have to. Well done.